Hi, good day. My name is Ajibade from the Department of Computer Science, University Technology Malaysia, and I will be presenting briefly on the topic analysis of meta-heuristic feature selection algorithm for classification. Classification is a very vital task that is performed in machine learning, and a technique used for classification is trained on various instances to predict the class labels of hidden instances, and this we call testing instance. The technique used for classification is able to find a connection between the class and instances due to the help from the training process known as attributes or features. And this research displays the feature selection techniques performances and are subdivided into two. We have the wrapper-based meta-heuristic algorithm and the filter-based algorithm. And we made use of two educational data sets. Four different classification techniques were used on dataset, and the outcome shows that the decision tree gave the best performance on the dataset. Furthermore, the result shows that the proposed algorithm, which named CHPSOD, has shined other feature selection algorithm in that it obtained best classification performance. In recent times, technology and its utilization has been on the increase, and this has given the platform for so many datasets to be produced with massive number of features and a few patterns for classification. Classification plays a vital role in determining. In a classification problem, an algorithm is trained on several instances in order to predict or forecast the class labels of unnoticed instances, and these are referred to as testing instances. To discover an ideal set of attributes or features, as properly called, there has to be access to the conceivable with likely sets of attributes. These considered together with the expected subgroups of the attributes are confined in the full exploration space. And what it shows is the degree of exploration space. That is 2 raised to power n, and n is the unique attribute quantity. In any case, this activity can't be considered since it is too expensive and prohibitive practically. So this sort of selection of feature strategies, of feature techniques, is isolated to two classification techniques, that is the wrapper-based and filter-based. In wrapper-based, an attribute subset is assessed by the performance of classification of a particular algorithm used for classification, while for filter-based, it evaluates the feature subset quality in an autonomous method of any classification algorithm. So we made use of the PSO majorly, and the PSO was hybrided with other techniques. And this PSO has different various challenges, such as being converging at local optimal, slow convergence, computational time, and so many like that. So to eliminate the challenges and difficulties of PSO, we introduced the chaotic map into PSO. This chaotic map helps to improve the performance of PSO, and also we further introduced the DE, that is differential evolution, into the chaotic dynamic weight particle swarm optimization. PSO stands for particle swarm optimization. So our proposed method, which we call the chaotic dynamic weight particle swarm optimization, known as CHPSO, is enhanced by introducing DE, that is the differential evolution. And the reason for this is so as to eliminate some of the weaknesses of DE, of PSO. PSO usually converge at local optima, and then they converge computational time also is usually long, and also the some other weaknesses are mentioned in the research. So there are quite a number of machine learning languages or computational techniques such as ANN, SVM, NB, DT, which we used in our research work. But the purpose of this study is to evaluate the performance of various feature selection algorithms on different classification techniques by using some educational dataset to investigate if a better classification performance can be obtained with fewer features, or it will require more features for a better classification performance. So we want to know if we can obtain better classification performance with fewer features, or we will obtain better classification performance with a higher number of features. So, and we use two data sets. The first one, both of them are educational data sets, and the first one is known as the ZAPI educational data set. We call it the ZAPI educational data set, which has 16 features and was actually used by 500 students. And then it has different categories. They have the academic, the demographic, the behavioral. While the second dataset was gotten from the UCI repository database, and is known as, we call it the UCI student performance dataset. It involves 32 features for two courses, mathematics and Portuguese language. So here is the results. We compared our proposed algorithm, which is known as CHPSOD, with filter-based selection algorithm. Now, in the table 1, the table 1 is shown in the next slide. KLD technique. KLD is it's a feature selection technique. Gives an average result of 67.02 with 12 selected features. So what this means is that the KLD techniques gave the average results. This is the average result that the result gave with 12 selected features. This is for the first dataset, the ZAPI dataset. So with 12 results, that's the minimum it can go. It gave us 67. The information gain gave an average result of 75.35 with 9 features. So it was able to reduce it to 9. So with 9 minimal features, we were able to get average results of 75.35. And the CFS shows an average of 76.31 with 6 selected features, while our proposed algorithm gives an average value of 78.77, making use of 5 selected features. So from this result, we can see that our proposed algorithm actually gave the best accuracy, average accuracy, 78.77, and then this was gotten using the most minimal selected features of all. That is 5. It was able to use 5. So that means with minimal features used, we're able to get a better classification performance. Other ones are just redundant. We can see it here. KLD images of 12, IG 9, relief F 7 and 6, CFS 6, and then our proposed algorithm 5. Also from the table 2, the KLD gives an average accuracy of 75 with 16 features, while information gain technique gives 77% with 7 features. The relief F gives 76.56% with 8 features. And then our proposed algorithm gives 78.49 with 7 features. So we can see that with 7 features, our proposed algorithm gives the best value, which is 78.49, which is seen here. Even though IG made use of 7 and our proposed algorithm made use of 7, but then our proposed algorithm was able to get a better classification accuracy. Now we compare our proposed algorithm with wrapper-based Metaheuristics feature selection techniques such as D, GA, PSO. D, differential evolution, GA means genetic algorithm, and PSO, particle sum optimization. So from this result, we can see that our proposed algorithm gives the best accuracy of 78.77 with 5 selected features. So others made use of 8, 10, 7, and our own gave 5 and also gave the best accuracy. So that means our proposed algorithm is better than other meta-heuristic algorithm, and this is represented in the table. Also, we see for table 4, which measures for the second data set. Comparing the meta-heuristic with the proposed algorithm using the UCI student performance set from the UCI repository database. Our proposed algorithm also shows an average accuracy of 78.49, which is better than 77.59, 74.52, and 76%. And it measures of 7 selected features. At least that's the most minimal, which proves that our algorithm is better than others. This also is represented here in this table. Now, of course, we have to validate and evaluate the performance of the feature selection algorithm using the educational data sets. So to validate the performance of our algorithm, we make use of the evaluation techniques such as precision, recall, and F-measure. And the results for the XAPI educational data set is shown in table 6. So this is the results for the evaluation of the filter feature selection techniques for the XAPI dataset, and then this is the one for the meta-heuristic. So from the results in table 5 and table 6, the proposed algorithm gave the best performance. Our proposed algorithm actually gave the best performance for all of them. And the same thing also for the second dataset. This is for the filter based, and then here is for our proposed algorithm. And in all, our proposed algorithm was able to prove itself better than the other algorithms. So this study investigated whether a higher classification accuracy can be obtained with minimum number of features, which was proven that our proposed algorithm gave best accuracy or higher classification accuracy with minimum number of features. And also, the proposed algorithm was compared with meta-heuristic algorithm, other meta-heuristic algorithm. Those are the GA, the DE, and the PSO. And the proposed algorithm gave a higher classification performance, that is a better performance than the other meta-heuristic performance. Thank you so much for listening.